Hi everyone, thanks for joining us inside the Lightroom Research Lab. Today I'm going to show you the work that I have worked on this week, and I have worked on two things. First thing is like calibrating the camera, from making it from 2D guesser to 3D calibration, like measuring the distance of the cube from different distances. Before it was like just guessing the cube's location, because whenever it sees the cube on the camera frame, it's just guessing it like from the pixels. But now it's like more calibrated, and we have calibrated the camera by taking like different images or different pictures. If I can like show you, for example, here we have like a different images of the checkbox, this box. We have took like 50 different images of this checkbox, and we have calibrated the camera. It's like before doing this, it was like a camera was just seeing the blurry images. For example, if you can assume the human is like without the glasses, we can see like just the blurry images of the persons or like the people standing in front of us, but we didn't know like where they are standing or what's their exact position. The same case is here with us with our camera. We know that we can see the cube from the camera position, but we don't know like where this cube is like located. But after calibrating the camera, we can like see the exact position of our cube. For example, here we can like make the 3D space or 3D plane of this cube, like with all different sides, like having four different sides, and we can also know the distance, like how much our cube is like far away from our camera screen. As you can like see, here is like distance 377 millimeter. So yeah, it's like before doing these things, it was like just the camera guessing the cube in the space, just like a 2D guesser. But after calibrating the camera, we are giving the camera like the prescription type of thing, like this is your focal length, this is your center X, center Y, and like before giving us like the exact position of the cube, you have to like calculate these things before giving us the exact position. And yeah, before using those things, we were just guessing, and now we are having the more exact position of our cube. This was the one thing that I have worked on this week. And other thing we have worked on, like the setting up our Isaac Lab setup. It's like a virtual environment where we can like train our robots. For example, via reinforcement learning, we cannot like practice or train our robots just in the real environment. It's like taking so much long time. So we need some sort of virtual environment where we can like train our robots in the simulations. But the hard thing was we are using the headless environment. For example, our server. Normally, whenever we are like running this software, it's like we assume that we are having a screen, but in our server we don't have the screen. It's just the headless. We are having the terminal. We need to run our software on that terminal, and we have to access that terminal via some remote connections or by opening some ports. So we were like having the challenges, for example, rendering the GPU without a display, using the SSH tunneling to access the ports, and enabling the ports, for example, the TCP ones and the UDP ones. And then after enabling those ports, we have to forward those ports into our local host, for example, in this case, our MacBook. And yeah, and to run the software in our server, for example here in this case, we are having our Docker image of our Isaac sim, and this container is inside our server, and we will just run this container inside our server. For example, now as our server is like running our Docker container, and when our Docker container is started, we can like access the headless environment, like the GUI of our software, via localhost of our MacBook. So it will just take like 30 seconds, and then we can access our headless environment via WebRTC. This is like a virtual environment where we can train our robots virtually, because in the real time it's like taking so much long to train our robots. But if we are having our virtual environment, we can like train the multiple simulations to train our robot just virtually. For example, now we are connected to our server, and now we can start our GUI space here. Like for example, here in this case, we are having our GUI of the software, and for example, we can like create a ground plane. Now in this case, we are having our ground plane, And we can also do some examples for now. For example, in this case, we are just having a simulation example, or just the example of a one robot, and we will do same thing with our robot. We are having a virtual environment. We can like move our robot like this way. We will create a same virtual environment for our robots, and we will train our robots in this virtual environment. And you can like close, zoom in, zoom out, or like train your robots as the way you want, like rendering like 50 simulations, 100 simulations. For example, in this case, we are having a humanoid robot, and we can like simulate or like move this robot as the way we want. We will do these things same with our robot, simulate the things, import the robot templates, and we will train our robots here in this virtual environment.